actually from, I think, the 2006 exam, and it's the third question. So kind of a middle of the road difficulty question. It was the first no calculator question in 2006. The format was a little different, but nonetheless, this really relates to some of the things that we've done up to this point. So including the stuff that we did this week and last week, really last week. But so we're given this graph of f, and then we're given this function g that's actually the integral. So the area under the curve, or in between this curve and the x-axis, from 0, so giving you a starting point at x equals 0 to an ending point, well, wherever they've decided. And oftentimes on this when you get a problem like this, that's part A, is asking you, well, evaluate g of a number, in this case 4, g of 4, g prime of 4, and g double prime of 4. So they're asking you to look at all kinds of different things on here. So know that if one of the important things to know on this is that if g of x is equal to the integral from 0 to x of f of t dt, then g prime of x, if we differentiate the left side, it would just equal f of x. And if we take the second derivative of g, we will get f prime of x. So this is the area of f. This is the value of f, and this is the slope of f. So you have all of those things with this graph in geometric shapes. So take g of 4. So let's start with this, and I'm going to have to scroll up and down, just so you know. I'm going to have to do my best to scroll up and down, but hopefully you can either print out the answer or the problem in general. So part A, g of 4. So when we look at g of 4, that would be the integral from 0 to 4 of f of t dt. So when we think about what that is, that's this area from 0, that space, plus this space right here. There's a lot of different ways you could do this, but it is that space. So, you know, we could calculate the area of this part right here. It's 1/2 the base, and then the height is -2. Notice that if we divide this up, this is 1/2, 1, and then times 2. This one over here is 1/2. Base is 1, height is 2, and area right here is 1 times 2, or 2. So if you're calculating this, you just want to string that together. Again, you don't have to do the arithmetic involved with it. You just have to string it together. So you just literally have to say, okay, this is equal to 1/2 times the base, which is 1, and the height, which is -2, plus 1/2, 1 times 2, plus 1 times 2, plus 1/2, 1 times 2. And you could do the calculations if you want, or you can just leave it like that. That is a fine answer. It's just arithmetic now. And what that's doing is I'm adding those 4 sections up there that I divided that orange part into. Okay. Now, in the next part, g prime of 4 is also equal to f prime, or f of 4, right? G prime of 4 is equal to f of 4. That connection is an important piece. It's actually worth a point on the exam. So that's happens to be just the value at 4, which is right there. That value right there. F of 4 is equal to 0. So the answer to this is just 0. Finally, G double prime of 4 is equal to F prime of 4, which is the slope at 4. Slope of this line at 4 is down 2 over 1. So the slope of this line is equal to negative 2 over 1. You can leave it like that. I would always kind of encourage you to leave slopes as fractions. I think that it shows that you know what you're getting and that you didn't forget to divide by something, but that's the answer to that. So negative 2. The answer key will simplify, that, especially that first one. Now, let's look at the second part of this. Part B, I'll do it in a different color. Part B says, does G have a relative minimum, a relative maximum, or neither at 1? Okay, so let's go to our chart. If G, which, remember, when you think about what G is defined as this integral from 0 to x of f. So then G prime is equal to f. And then G double prime is equal to f prime. So when you have a relative minimum, G needs to go from, or maximum is if you go from increasing to decreasing, the derivative is going from positive to negative. So, you got a relative minimum this way. And if you go from this line to this line, you got a relative maximum this way. So what you want to look at is, well, what's happening at G when x equals 1? When x equals 1, if we look at our graph, when x equals 1 right here, notice that we're going from negative values to positive values. If we're going from negative values to positive values, and this is the same thing as G prime, then we know that this is a relative minimum for G because G prime is going from negative to positive. At x equals 1. So that's how you'd answer part B. So pretty easy, kind of, the only difference than what we've had before is how we define that first function and then building the rest of the chart off of it. Now, usually problems get more difficult as they go. So A is relatively easy, B is it's maybe a little bit more difficult, C is going to be the most difficult unless there's a D, and then that's probably the most difficult. But there's always to be things to be had in those latter portions of an FRQ. So don't think, if I didn't get A or B, I'll never get C. Just give it a shot. Okay, so let's look at C. So C says up here, it says, suppose that f is defined for all real numbers and is periodic with a period length of 5. The above graph of f shows 2 periods. Given that g of 5 is equal to 2, find g of 10, and then write an equation for the line to the graph of g at x equals 108. Okay. So if we kind of think about, how we might do this, here's what we got to kind of think about. I'm going to erase all of this stuff in here so I can rewrite over it. Okay, so hopefully you're okay with it. You're just re-erasing this. We're going to look at this. So if you think about g of 0 would be the integral from 0 to 0 of f of t dt. If we start at 0 and we end at 0, we've gone nowhere. That's basically 0. So what you want to kind of look at is they tell you g of 5 is equal to 2. That's one period length. So think about what that looks like, and why would it be that? Well, think about one period on this. One period is this space plus this space plus this space. But what I want you to pay particular close attention is notice that this space and this space and this space and this space, together, those three spaces that I marked with red dots is 0, and this right here is 2. That's why the integral from 0 to 2 of f of t dt is equal to 2. Sorry, integral from from 0 to 5 is equal to 2, because we get some cancellations out there. So it would make sense that if this graph is periodic, it's going to continue this pattern. And it's going to continue this pattern next, and it's going to do the same thing. It's going to go up here, it's going to go across here, it's going to go down here, and when it does that, this value is going to be 10, because each period is a length of 5. So what you should think about is you should say, oh, well, what that means is that when we're doing part C, if g of 5 is equal to 2, g of 10 is equal to 2 times g of 5, or 4. That was worth 1 point. Okay, just kind of realizing that must be the answer. Now the next question comes is, okay, well, what are we going to do for the second part, which is write the tangent line at x equals 108. What we have to do is we have to kind of visualize continuing this graph all the way out to 108 and kind of think about, well, what are we going to get to? Well, notice that it goes up by 5s. Every 5 it repeats. So every 5 it's gonna go over and over and over. So what you have to kind of think to yourself, okay, for a tangent line, let me back up and remember tangent lines. Tangent line generically is y equals f prime of x times f prime of a times x minus a plus f of a. And that's generic, right? So that's not talking about our function f in this case. For our tangent line, for this particular problem, in this particular problem is y equals g prime of 108 times x minus 108 plus g of 108, because that's what we're dealing with in this particular problem. So here's the things we need. We need g prime of 108, and we also need g of 108. Well, if you think about what just happened in the last problem, when g of 10 was 2 times g of 5, we should know that this thing repeats every 5 units. It repeats. So g of 108 is the integral from 0 to 105 of f of t dt plus the integral from 105 to 108 of f of t dt. Now, you think about what happens. Well, notice that 5 goes into 105 21 times. So this is 21 g of 5s. This is 21 times 2, or 42, right? But then we have to do plus. Now, 108. So let's go back up to our graph, and I want to kind of reset this graph. And what I want you to kind of think about is this. If you kind of ignore and say, well, I'm not going to think about this as being the x-axis, or sorry, I'm not going to think about that being the x-axis. I'm going to kind of think about this value right here is also 105 because it would have repeated. You know, when x equals 0, x equals 105. So this would be 106. This would be a 107. This would be 108. So when you think about what's happening, the integral from 105 to 108 of f is the same thing as the integral from 0 to 3 of f. And when we think about what that looks like, that's this space minus this space plus this space. Again, when you think about how this would be divided, these two go away. This is 2. So this answer is just 2. Well, now if we piece those together down here, we'll end up that this is equal to 2. So this is 2. This is 2. So the answer is 44. Now that's the value of g of 108. Now, g prime of 108 is the same thing as f of 108. But if you remember from our work just a minute ago, 108 is also the same as 3. And so at 3, the slope, or the value, is 2. So this is f of 108, which is also g prime of 108. So we know down here, sorry to scroll, but I have to do it to get this, that we know this is 2. So then we just plug in our values to get our tangent line. That means our tangent line, our answer is y equals 2 times x minus 108 plus 44. That right there is our tangent line. Coming up with that is the last 3 points. Go ahead and grade yours, see how you did, and if you have questions, please ask me.